Hello, everyone, and welcome to another Elastic virtual meetup. We're so excited to have you join us today. We'll go ahead and get started. As usual, I have a few agenda items to cover. First, we'll do some welcome and introductions from the Elastic team. Real quick, my name is Olivia. I'm a DevRel program manager at Elastic. I'm also joined by Justin.
Hey everybody, Justin here, Senior Developer Advocate at Elastic. Happy to be here.
Perfect. So next I'll cover some upcoming events. We'll have our usual meetup raffle. I'll share some resources on how to get involved. And then we'll kick it over to Leo, our featured presenter. At the end, as usual, we will have Q&A with Leo and Justin. So post any of your questions in the chat and we will either get to them if it's something that we can answer during his presentation or save them for the end. So upcoming meetups, this is just a list of events in US, Latin America, and Canada in the next month and a half of what's currently scheduled. We do have events in Europe and Asia, so be sure to check out our meetup dashboard where you can take a look at all of our upcoming events, regardless of the city, and you can subscribe to stay up to date on what's happening in your neighborhood. As usual, we have our meetup raffle. If you want to enter our raffle for a chance to win some Elastic swag, we'll post the URL in the chat and then feel free to enter that. I will contact the winner after the presentation today. Some resources, as usual, I wanted to share a few of our DevRel specific resources. So if you have Elastic questions, definitely take advantage of our community YouTube channel. This is where we have a lot of great information put on from our community, our internal Elastic team. We also have Discuss. That is a forum where you can get your questions answered in real time from other members of the community and Elastic employees as well. And then our Slack workspace is great as an option for questions, announcements, that kind of thing. Next up, okay, so what now? If you are interested in presenting at a meetup, whether it's in person or virtual like this one, we want to hear from you regardless of your Elastic expertise, advanced, beginner, intermediate. Feel free to reach out to meetups@elastic.co. We'd love to hear from you. And then again, take a look at upcoming events in your neighborhood. I'll post all these links in the chat here shortly. But with that, I will turn it over to Leo.
Hi, good morning, good afternoon, everyone. My name is Leo. Today I'm going to talk about scaling Logstash with BGP. I'm a system engineer with Breckinridge Capital Advisors. Next slide, please. Disclaimer, this is my engineer point of view, how to tune Logstash using industrial standard protocol, and this is not affiliated with my employer or my employee view. Next slide, please. On today's agenda, I'm going to go over a quick intro, some techniques. Oh, I think we have the slides coming up. Give it a second.
Sorry about that.
Oh, no problem. Oh, just let me know you want me to go.
Yeah, you should. Do you see the slides on the main screen now?
I have mine, but I don't see it on the live one, so I don't know if you're sharing already.
Okay, I'm sharing. Olivia, can you see it? Sorry for the technical difficulties, folks. Let me just check this real quick. Okay, it looks like Olivia added her slides. Are you able to see that?
Yep.
Okay, cool.
Great. And I'm going to assume all the participants are able to see that. Okay, great. So, so to recap, so today's agenda, I'm going to a quick intro, some of the techniques on scaling Logstash, some traditional one with clustering, load balancing, or share queues. And I'm going to talk about why we're using BGP on some of the config. And at the end, I'll talk about Anycast as one of the very key elements we able to scale Logstash with BGP. Next slide, please. So about me is I'm an infrastructure engineer. I started working with Logstash version 6, I would say since 2017. And I remember the years that when Logstash introduced a multi-pipeline feature. I was super excited about that. So I started as a consumer using Logstash. I was very new and I was very excited and happy when I started using Logstash. And then after I start moving on to a different role, different company, I was still able to work with Elasticsearch. I was the sysadmin, maintain the Logstash cluster, able to get it up and running. And then on my recent role, I become more a application owner. Logstash is still my go-to to ingest data, but I'm more stepping down on the sysadmin side because I've been using Elastic Cloud on either on the personal or my last role. And you see the teacher, I probably will be the second guy to the right with some beer, even if it doesn't look like me. But I've moved on from more sysadmin side to more a infrastructure side, using Logstash as more a log ingestion. Next slide, please. Oh, next slide, please. I mean, there might be some difficulty. I'm going to give a couple minutes for the slide
sorry
to.
about that.
Yep.
Okay, here we go.
Okay, thank you, Justin. Yep, so I'm going to talk about the clustering, load balancing, and share queue. Those are, I would say, some of the key techniques that I've worked in the last 7 years, give or take with Logstash. Next slide, please. So first, with the clustering, some of you might be familiar with this, with the clustering. So you have Logstash instance, 2 or more forming a cluster. They're sharing the same configuration input, and this is a use case what I see for what I call this small deployment, where you have 1 or 2 data center, and you have logs. You have input syslog, application log database. They were all sitting in this data center in the same geographic location, and then you want to get it into your Elasticsearch cluster, and this. I'll say it works pretty great. Next slide, please. And during the clustering technique, the one that I use, or some of you may be familiar, is Pacemaker. In Pacemaker, you have the XJ Cluster Resources Manager that maintaining the resources for both of the node, 2 or more, and you're running in a failover cluster, and you're using the virtual IP to switch over if one of the instance fail or does not respond. And this approach I normally call the PAT approach that some of you may hear or some of you might heard, is we normally treat this very, I would say, carefully, because normally when you upgrade the config of Pacemaker, the cluster may have issue with the versioning. So looking at the screen on the right, you have a code snippet where you define your resources. You have timeout, stop timeout. You also have your heartbeat, and then you have your virtual IP div in the middle. And then last but not least, you have your Pacemaker configuration. You defined it where you can set up the quorum policy, you can set up bootstrap option, or you can use CoralSync. And CoralSync is a messaging or membership service for the cluster. And that is a short configuration for the pacemaker. Next slide, please. And one of the issue I have seen with pacemakers that is very depending on each other, and sometimes it may create a circular dependency. And if that happens, I have seen that the pacemaker may start to stop resourcing correctly and will fail to start. So if you look at a pacemaker point of view, a VIP is a resources, a Logstash is a resources. So all the component is a resources, and for it to start and stop, pacemaker will adjust the resources so it can actually align to start correctly. And sometimes when you have a different or many resources run in a cluster, you might find a trouble maintaining all the resources. Let's say you want to upgrade Logstash, and then you need to making sure you stop one of the node, you upgrade Logstash, and I have seen that the horizontal scaling with large number of nodes become an issue, and managing become an overhead because now you have a dozen of the pacemaker cluster running in your data center, and you have to keep track of which one you have maintaining, and you have to making sure the start and stop order have to be precise, or they won't start the Logstash resource correctly. Next slide, please. And next we have the what I call the load balance. So the load balance is more a modern approach that I've seen on a lot of deployment. And in load balancing, most of the popular method we have is round robin least connections, or IP hash. So round robin for the round robin techniques, each incoming request they send to the next Logstash server from a predetermined sequence. So what I mean is that it's coming in. So let's say you have Logstash 1, Logstash 2, each one will be round robin to each other, and then making sure all the resources is load balanced correctly to making sure the resources is distributed evenly. For least connections, the incoming request sent to Logstash, they tracked it by what we call the fewest active connections. So let's say you have five connection making to the load balancer, and you have another 5 or 6 connections coming in. The next one after will be hopping on the least connections to making sure the resources sit behind the Logstash is distributed evenly. And last but not least, we have the IP hash method. The incoming request that tracked it or directed is based on the client IP. So let's say you have 2 data center, one in US, one in Europe. You can base it on the IP address of the source client that's sending the traffic, and you can direct them based on the client's IP address. And the session persistence is a relatively important topic because all the incoming session from a client that directly to the same server for a specific period, you can define them. And I have noticed that when you are playing around with that session, sometimes it might lose to have duplicate data when you are setting the persistence too short. I'd like to highlight that out. And load balancing support HTTP, HTTPS, TCP, and UDP. And for most of the deployment, I've seen they're using TCP because they're more reliable than UDP. And this one, it's what I call the kettle approach, because for this kettle approach, you can remove and add Logstash server without worrying about log ingestion or data loss. And last but not least, I would like to touch up on SSL termination. So I have seen some of the deployment where the traffic need to be encrypted. So on the load balance side, which I'm going to talk about in the next slide, is HA proxy. They can terminate SSL or TLS encryption. So what happened is that the load balancer, they will decrypt the traffic before forwarding to a Logstash instance, whereas the SSL or TSL pass-through, they basically send the encrypted traffic directly to Logstash without decrypting it. And the reason I want to mention is that because I've seen sometimes with Logstash we have issue after the traffic going through the HA proxy or the load balancer after the traffic has been decrypted. Next slide, please. So for load balance config, in this slide, we have a config snippet where it's running on mode TCP, which is layer 4. And for the balance round robin, this means that this directive is set the load balancing algorithm to round robin, and HA proxy will distribute the incoming connections evenly across all Logstash server in a circular manner. And for the front end, you will have the Logstash definition, and this represents the entry point of the connections. And on the back end, you have the HA proxy represent the group observer where the connection will be forwarded to. So let's say you have a dozen of the Logstash server, you can just add it in your HA proxy config. And to add or remove, you just have to remove it and add it in the back end. And all this is very seamless on the client point of view, very seamless. Next slide, please. So this one, it's a load balancing one in HA proxy is active standby mode. So an app will send request to the HA proxy server as an entry point in the bottom. And this one, on the HA proxy, the logs, the application will forward that to 10.0.0.10. And then after that, they will get routed to keep alive D. And then HA proxy next, they will forward the request to the selected backend server. And then last but not least, on the backend, Logstash, they will process the request and send the response back to HA proxy. And this is how a typical, say, called life cycle, or when a client interact with HA proxy. Next slide, please. So next, I'll touch up the last traditional method, which is the share queue. And this one is most of the modern approach that I've seen in my experience, where all the instances they consume in a what I call single queue. And if one of the instance fail, the other contingent will consume event from a shared queue. If you think about queue is when you're lining up, you have a lot of let's say a client's coming in, and then you have Logstash sitting behind. So even when it fails, the other will keep consuming the queue from the Logstash will keep consuming from the queue until the last. As long as you have one Logstash, you'll keep forwarding that to your Elasticsearch cluster. And what the difference this approach with clustering and HA proxy, that this one is decoupled from the log sources, which is going to play effective when you have a lot of different log sources coming in. Like say you have app logs, you have syslog, you have application log with different type. And this will come effective when you have different pipeline, or you have a lot of data coming that you want to have a unique approach to direct your traffic based on either the pattern or based on the source, and you can send it to a different pipeline. So this one, the Logstash consumer from the share queue, and they process it and output them as configured. Next slide, please. So in this one, I'm going to use Kafka example. So Kafka, as most of you might have, they're able to handle the search in the data. They're able to buffer it until the Logstash can process this. Logstash has a built-in persistent queue able to handle the buffer, but by using a shared queue versus the persistent queue in Kafka, we take off some of the load from Logstash. So Logstash can focus on some of the filtering or some of the data manipulation without worry about, all of a sudden I have 10 gigabit of data coming in, and then Logstash all of a sudden got overwhelmed with processing the data, and then if there's an interruption or if there's an outage, all data will be either routed to the persistent queue. If you don't have share queue, or the data will be lost. And for routing, the Logstash can use the topic field in the data source to route the events to the specific pipeline. If you have 20 pipelines, you can just write it based on the data, based on the topic field. Next slide, please. So this is a typical config with our Kafka. Some of you may have recognized, I have write this before. So you're able to use regular expression to define syslog format based on info, debug, warning. But as you've seen here, when you start expanding the regular expression, it's not easily maintained and it's getting very complicated. And Regular expression is a very memory and process intensive because they have to scan the file line by line. And even though you have your Logstash have a very high CPU and memory configuration, sometimes it'll get overwhelmed and you can see delay on writing it if you have a long regular expression written within your Logstash config. Next slide, please. So for the share queue, this is a sample config when you have Kafka defined it. So Logstash here is configured to consume the log data from specific Kafka topics by using the input. And then this one, they can able to route to different pipeline using specific topics. It's a simple if statement. So on the Kafka point of view, you create topics for different log types. So app data, database data, you name it. And then after that, you will configure Logstash to consume the log data from specific Kafka topic using the input plugin. And then after that, Logstash will subscribe to specific topics and allow them to receive the log data. And then it will use the topic field to route the data to specific pipelines or input. And then we have a simple conditional statement to allow us to send it based on different topics or name. Next slide, please. And I have spent 20 minutes talked about a lot of different methods that we have used or I have used in the last year and why we're using BGP. So before I get into be specific on the BGP, I kind of want to use a simple analogy, why does it matter and what is it like? So some of you might heard of, each of us, have lived in a city and you will have, a mailman who know to get to the letters. And when we get a letter, each of the mailmen go to a different post office, they hand the letter and the post office will send it there. And the system in here will have the best road to get to each city. And the mailman will look up the address. Hey, this is the address of ABC Street. It'll forward to other mailmen. And BGP is like big network of mailmen, in each different city. They're able to send package or letter to different destination. And what I would like to highlight is that BGP sometimes may not able to get to there by the fast path, but it's what BGP do best, able to get to by the best path. So in here, each city is more like a network, and each mailman is like a router, and able to how to get the package to the city. Next slide, please. So going back to BGP here, so BGP is able to allow us to internet work, and it enable the routers in different autonomous systems to exchange routes, and that's how we make up the internet. For BGP router, like I mentioned before, it doesn't necessarily able to give you the fastest path, but it gives you the best path. I would like to highlight this for this presentation is that because BGP is known able to handle best path selection, and we can able to use the policy to influence some of the traffic to get to one place to another. Next slide, please. So in the BGP point of view, you have a router defined it over in a data center, and first you would pick a router ID, you pick a peer group, you pick a neighbor, and this configuration is forming with the Logstash server. So what it means is that this particular router, let's say we have a data center in Boston. So this Boston router will knows about this Logstash in this network. And each of the router, they can pair up with different Logstash. So in the config here, we see that the router itself, they pair up with two Logstash server, 10.0.2 and 10.0.3, and is know where it sits based on BGP. So this is a simple config where you defined it on a router, whatever brand. They will have different syntax, but this one is running FRL. Next slide, please. So this is a diagram, a pointer to give you a better representation. Over at the bottom, I have the Logstash server running BGP. At the top, we have two leaf switches running BGP. So in here, Logstash will start advertising itself to both of the switches. So let's say if someone is talking to leaf switches 2, they will know about the Logstash server sitting at the bottom, 65503. And if someone is or client talking to leaf 1, they will able to know about the Logstash server sitting at the bottom. And if we multiply that by 10, we're actually building up a network of Logstash server with different switches and in different location. And we were able to build a map. And when we able to request getting to Logstash server, it will able to get us to the path, because BGP will advertise the route towards the Logstash server and present to the client. Next slide, please. So this slide is talked about the BGP configuration in the Logstash point of view. Most of you is pretty familiar. We have NetPlane here, and the IP address on the right, the 1.2.3.4, is the loopback address that will be presented or sent it to the client. So if you have a syslog server, you're sending it to 1.2.3.4 on the syslog point of view, I will have 2 paths or multiple paths to able to get to Logstash, because leaf 1 or leaf 2 will present us all those available paths to it. And if the path fail, then the other path will become active immediately, and the application or the syslog that forwarding to it will know nothing about, because it's get installed on the routing table by leaf 1 or by leaf 2. So the logical steps in here to highlight is you configure the FRR or Anycast loopback address on your Logstash server. You configure loopback address in NetPlane, and then you configure BGP peering with your neighbor devices. And then after that, you want to making sure the router is forwarding the loopback address to your client. So if you do a checking the route table, you should able to see 2 paths going down to Logstash, the Logstash server on the bottom, 65503, because that's the neighbor that advertising what available routes that I'm available to both of the leaf switches. Next slide, please. So to put it all together, I have a sample diagram that how would this or able to put in a use case. So over here in the screen, you see that we have a site A and site B, and we have clients in the bottom. And each of them is pointed to 1.3.3.4, where all the Logstash have the same loopback or Anycast address. So on the client side, they will able to have the the route present to them, and the route is being maintained by the switches that I mentioned it on the previous slide. So the dotted arrow is all the available path on the switches point of view, and this is called like invisible, because the client will always have one active route present to them. So when one blocks the server is get removed, they will get the dotted line, they'll immediately become solid, and the client will route that immediately without, I would say, sub-second, because BGP already have that in the routing table, so it doesn't have any failover mechanism. This is all done on the layer 4. And what interesting in here is that if we want to remove the Logstash server from site A to site B, most of the time you don't have to do anything, because they already on the routing table on the switches. And one thing in BGP is that you can also configure ECMP. You can also configure load balancing. So let's say on site B, you can distribute all those traffic on both site A and site B based on your configuration. So that's a lot you can manipulate with the BGP attribute, which is beyond on this talk. But to keep this short, with BGP, you can write a pretty complex, routing policy. You can say, hey, I want to offline site A Logstash do an upgrade. I can write a routing policy, And after the routing policy is in place, all the solid line in site A will become dotted line, and the one that pointing to site B will become active, and all the client would not know which Logstash is sending to, because to them, they're all pointing to a single Anycast IP address. And this is today to talk about the Scaling Logstash BGP. Does anyone have any questions?
Hey, Leo, thank you so much for that presentation. We'll stay online a little bit for some more questions, and apologize about some of the technical difficulties before. We're just trying to balance everything between Seattle, Denver, and I imagine Boston. So it comes with some challenges. So I have a question about BGP. Where can I actually access this technology and like find some documentation on it?
So that's good questions. I can put some links in there. So in a typical deployment, this is in running Linux, you can install free range routing, aka known for FRR. Once you install FRR, you were able to configure BGP. And the configuration is available in FRR because FRR is an open source routing, dynamic routing suite. It will have all those information presented to you, and I can add that to the slides.
Okay, cool. Let me
That's a good question.
just add that to our. I'm just making a little bit of a recipe list in our comment section, just so everybody can see what they can access. And I noticed between Beats and Logstash, you're using Kafka. Would any other streaming data structure provider work, like Redis or anything similar to that?
Yes, so the question is that aside Kafka with Redis and Redis works, yes, they all work on a similar function. It depends on the architecture. So I think I use Kafka only because it's probably most people heard of Redis, Memcache. They all work similar, but they all function, fundamentally they work, very similar. The purpose of the share queue is to take off the load from Logstash. So when you have when one of the app owner decide to send 1 terabyte of data toward your Logstash cluster, all your Logstash cluster won't just start giving up because they have to take on all the load. And your share queue will work as a buffer, will control those queuing, and the Logstash will continue able to stream it to your Elasticsearch cluster.
Okay. And would you recommend employing BGP starting out, or when you start getting to these scaling pains?
That's an excellent question. I think it took me 6 years to learn. I think I started off as a sysadmin. I have used all those methods in the slide. I would say if you have network engineers sit next to you, I was checking with them more or less. If you're running in a multi-data center environment, I am pretty sure you have BGP running already. But if BGP running in the data center, you will have to check with your fellow network engineer, because what I find is that BGP in a data center is still a relatively new deployment, even though BGP is been around for a long time. So I would say I would start testing in the lab, because not all your switches connecting to your Logstash server is running BGP already. So I would start off at that, and then check if your fellow network engineer, if you have one sitting next to you, and if you know some network already, you can start testing around BGP in how to pair that with Logstash, because this is you can actually set up pretty easy with your lab. You can use EVNG, or you can use NetLab to kind of simulate how BGP work, because that's 80% of the work that taking on the XJ part, and then all behind that is still the same typical Logstash work. So Logstash hasn't been changed. Is how we're able to decouple all those complexity using XJ proxy and all those load balance off to a industrial standard protocol that we've been using for a very long time. Mm-hmm. So I hope that I answer some of the questions.
Yeah, no, definitely. And this just highlights the importance of actually having a network engineer as a friend working next to you.
Yeah.
Thank you very much. And I just wanted to show a couple of things up on the screen. If you want to start with HA proxy, check out, we have some docs in Elastic about integrating HA proxy within Elasticsearch. we have a link I just threw up to free range routing, which will actually expose you to BGP. And then, as always, we want you to enter a meetup raffle for a chance to win some sweet Elastic swag. So go ahead and take a screenshot of that, or go ahead and go to the July 25th raffle from our ela.st Earl Schrittner. I am going to recommend that you go to discuss.elastic.co if you have any questions. That's our forum. All the developer advocates, as well as various different engineers, employees within Elastic, plus the Elastic community, will be there to answer any questions that you might have. Speaking of, you can also go to the Slack community workspace, where you can get a little bit more faster back and forth conversation going. So we have multiple different places to check out some Q&A. And then lastly, but not leastly, always check out our YouTube channel, Official Elastic Community, where you can see this video in syndication, as well as many other meetups that have gone on, and tutorials and things like that at your convenience. So cool. I don't see any other further questions or anything like that. Do you have any questions for the community, Leo? Or
I don't have any questions, but I may do another upcoming talk about how we're able to test that, because I think a lot of times able to get into using BGP deployment is tricky. So if once I have my lab up and running, I may do another talk, and I will get in touch with Justin Olivia.
Oh yeah, no, I'd absolutely love that. We could have a part 2 where you can get into the weeds and see the code actually in action. That'd be awesome. Well then, thank you everybody for joining us for this meetup. Thank you very much, Leo, and I'll talk to you later. See ya.
Thank you, Justin. Bye, everyone.